Hello, grade 7 students. In this video, we're going to learn how to draw the graph. In order to draw a graph, you have to use the data. It's available inside the table or in a text to draw the curve, which is the graph, or to draw a histogram or to draw a pie chart. Histogram is the shape, this is the histogram, or the pie chart, this is the pie chart. It's going to be divided, for example, 37%, 10%, and so on. So now we're going to focus about the graph. In order to draw a graph, you have to use the details of the document, the table, or the text. Mostly, it's going to be a table. You have to convert a table into a graph or a curve. You must add a title. So the first point, we have to add a title for the graph. We have to label the axes, the x-axis and the y-axis, with the variable and the result respectively. And you have to use the units and you have to put the scale. So first you have to put the title. 2. Label the axes, the x-axis and the y-axis. What is the x-axis? This is the graph. This one is called the x-axis, and this one is going to be the y-axis. This you took it in math in grade 6. So the x-axis and the y-axis. Number 3, you have to put the units. Number 4, you have to put the scale. Okay, let's start step by step in this application in order to know how to draw the graph, how to label the axes, how to know the scale, and to use the units. This application we're talking about respiration. Respiration will place a green aquatic plant in a large test tube. This test tube was filled with water. Then we connect an oximeter. Oximeter is used to measure the volume, the amount of oxygen gas, O2. So we connect an oximeter to the test tube to measure the amount of the oxygen gas. We start recording the amount of the oxygen every 1 minute. The results are shown in the table below. At the beginning of the experiment, when the time was 0, the amount of oxygen gas was 10. At time 1, the amount of oxygen gas becomes 8. At time 2 minutes, the amount of oxygen gas decreases to 6. At time 3 minutes, the amount of oxygen decreases to 4. 4 minutes, it decreases to 2. And at 5 minutes, it decreases to 0. So as you see here, as we move with the time, the amount of oxygen decreases. So the plant is using or it's consuming the oxygen gas. So amount of oxygen gas, it's going to be decreased by time. So first of all, you have to determine, in order to convert this table into a graph, you have to know which one on the x-axis and which one on the y-axis. Always the table, the one in the row above here, is going to be on the x-axis. Okay, so one above in the table should be below in the graph. So this is the x-axis and this is the y-axis. This is the x-axis, as we said before, and this is the y-axis. So always the one in the graph above should be below. So here it should be the time in minutes. This is the title of the x-axis. The y-axis, the one below in the table, should be above in the graph. So amount of oxygen gas for aquatic plant centimeter cube. Okay, this is the title for the axis. Okay, so let's move now to know how to draw the graph. So now we move to draw the graph. In order to start drawing the graph, you have to determine which one on the x-axis and which one on the y-axis. We said always the one in the table above should be below in the graph, and the opposite is true. So first, whenever you have to draw a graph, you should draw it using a pencil and you have to use a ruler. So first of all, let's draw the axis. Okay, this is the axis. First, you have to put arrows. Why arrows? Because we're moving in this direction. And why you have to put arrow here? Because we're moving in this direction. This is first. Second, I have to determine which one on the x-axis. So the one in the table above should be below. So the time is above in the table should be below in the graph. So time in minutes. And also here, and the y, it represents the amount of oxygen gas for aquatic plant, and I have to put the unit in centimeter cube. This is the title of the axis, and then we have to move to the title of the axis. It's done. Title for the graph. Title for the graph. Title for the graph, it's always graph showing the variation. You have to write always graph showing the variation of what? The variation of the y. The variation of the y, which is the amount of oxygen gas for aquatic plant, centimeter cube, as a function of what? Of the x-axis, as a function of time and minutes. So always, whenever you have to give the title of the graph, the title should be like this: graph showing the variation of, this is in all the titles. What is in the y? Amount of oxygen gas for the aquatic plant. This represents the y. As a function of the x, which is the time. Next, I have to move for the scale. To do the scale, or to find out the scale, we have to look to the x-axis and to the y-axis. We said that every box represents 1 centimeter, right? So simply you can do this. This represents 1 centimeter and this represents 1 centimeter. So simply you have to start with the scale. While using a graph paper, the graph paper is going to be 1 centimeter in the y and 1 centimeter in the x. They should be equal. With this paper, it includes a difference in the length between the x and the y. So this is the title. Let's start with the time in the x-axis. Here is the x-axis in the time. So as you see here, we're moving 1, 2, 3, 4, and 5. First of all, you have to know the point of intersection between the x and y. It's the 0. So moving one by one, we can move 1, 2, 3, 4, 5. So we move every box represent 1 centimeter. So 1, 2 minutes, 3 minutes, 4, and this is the 5. Okay? Then on the y-axis, so here every 1 centimeter represent 1 minute. So we're moving one by one. On the y-axis, 10, 8, 6, 4, 2, 0. So we're moving step by step by 2. So here it's 2, this is 4, this is 6, this is 8, and this is 10. Okay? Let's start step by step. At time 0, where's time 0? Here's time 0. Time 0, the amount of oxygen was 10. So you have to put the point here. This is the first point. At time 1, where's time 1? Here is time 1. The amount of oxygen was 8. So you have to move a line, roll here, a vertical line, and here a horizontal line where it meets here. This is point 8. At time 2, it was 6. So 2 till the 6. At time 3, it was 4. So time 3 minutes, it was 4 centimeter cube. So this is at time 3. At time 4, it was 2. So at time 4, it was 2. Sure, you have to use a ruler while drawing this. And at time 5, it was 0. So here, at time 5, it was 0. So in order to draw this, you can draw it with your hand here, and you can connect the points here. Okay, so on the y-axis, we took every 1 centimeter, it represents what? It represents 2 centimeter cube, since we move 2, 4, 6, 8, 10. So we move, skip by 2. Pay attention here. You can't start with different scales. For example, you start from first box is equal to 1, then you jump from 1 to 4. It's not true. So you have to pay attention to this. Okay, so the graph should have the title. This is the title. Should have the scale. This is the scale. You can draw. So moving to this table is showing the variation of the amount of oxygen gas in the control tube. Control tube, mainly the control, this control tube mainly is called the control experiment. This one is used to compare and to explain the results. And in the second tube, amount of oxygen containing the aquatic plant. This control tube containing nothing. So amount of oxygen, it remains constant. As you see here, it remains unchanged. It goes constant. So it stays constant at 10 centimeter cube. At the time increases from 0 to 1 to 3 to 4 and to 5. Whereas amount of oxygen gas for the tube containing the aquatic plant, it decreases from 10 to 0. At the time increases from 0 to 5. This, they want us to draw a graph that shows the variation of the amount of the oxygen gas as the function of time for both tubes. So this one is the title. This is the title here. You can give the title here. This is the title, graph showing the variation of the amount of oxygen gas as a function of time for both tubes. And they said plot on the same graph. So you have to plot them on the same graph. Let's start. So this is the table. First of all, we have to draw the axes. And then we have to move to the title of the axis. And this is the arrows. Title, this is amount of oxygen gas. What is the unit? It's centimeter cube. And here we have the time in minute. So title here for the graph, title, don't forget it, title, graph showing the variation of the amount of oxygen gas in both tubes A and B, or in both tubes as a function of time. This is the title. Okay, then I have to move for drawing the graph. Here we have 2 lines, so we have to draw 2 graphs on the same graph. We have to plot them, 2 curves on the same graph. So first of all, this is 0. Let's start with the scale. Scale, we have to move one by one. So this is 1, and this is a 2, this is the 3, this is the 4, and this is the 5 minutes. So here, don't forget the scale. Every box here, 1 centimeter and 1 centimeter. Okay? So 1 centimeter represent here 1 minute on the x-axis. Y on the y, let's take it 2. 2, 4, 6, 8, and here is 10. So every 1 centimeter represent 2 centimeter cube. Okay, so let's start. We have two tubes. First one in the control tube, and the second it's for the one containing the plant. Let's start with the one containing the plant. So at time 0 it was 10. At time 1 it was 8. At time 2 it was 6. At time 3 it was 4. And at time 4 it was 2. And at time 5 it was 0. So we have to plot the graph. This is the graph. Plot it using your hand. So the red one, it represents the one for the aquatic plant. So simply I have to give it a legend. Legend for this is going to be like this. You can use 2 different colors. For example, the red is one containing aquatic plant. And let's use another color here. Let's use another color. Let's move for the blue, let's say. Blue one is going to be for the control. Control, at time 0 it was 10, at time 1 it was 10, and 2 it was 10, 3 it was 10, at time 4 it was 10, at time 5 it was 10. So here it's a straight line. So this one is the control. This legend is very important. You have to know this legend and you have to follow and to give this legend. Since we have two curves, so you have to differentiate between them so you can use different colors. So the red for the aquatic plant and the blue one is for the control. So here we draw the graph, we give it the title here, graph showing the variation of the amount of oxygen gas in both the control tube and the one containing the aquatic plant as a function of time in minute. And here we give the scale, so every box here, even though they are not for 100%, so every box represent 1 centimeter. So every box here 1 centimeter, it gives 1 minute on the x-axis, and on the y-axis every 1 centimeter it gives 2 centimeter cube. Okay, so here we give it the title and we give it the legend and we have the scale for the axes, and here this graph for two curves, so showing the two curves. As a revision for the graph, first of all, the graph should include title for the axis, title for the x-axis and for the y-axis. Also, you have to give title for the graph, mainly graph showing the variation of the y with respect to the x and the function of the x. So graph showing, as in this case, graph showing the variation of the amount of oxygen gas in both tubes as a function of time and minutes. Number 3, you have to give it a scale. Always the scale, it can be like this. You can use this method. For example, every 1 centimeter on the x-axis, in this case, for example, it represents 1 minute. And every 1 centimeter on the y-axis represent, let's say, 2 centimeter cube. This is the scale. Number 4, you have to trace the curve. Okay, so these are the main tips for drawing the graph. Title for the x-axis and the y-axis. Always we said the above in the table should be in the lower part of the graph and should be on the x-axis. So in this case, the time is on the x-axis and amount of oxygen is on the y-axis. Title for the graph should be below the graph. Under the graph should be written. Scale, it can be written like this. Also, there is another method. You can say, for example, for on x-axis, 1 centimeter gives, let's say, 1 minute. On here, you can say on y-axis, 1 centimeter can give 2 centimeter cube. This is another method for the scale, but this one, I think it's easier for you. This is everything for the graph. Thank you. Bye bye.